Differentiation. Differential coefficient of or derivative of f of x is represented by f dash x or dy by dx. This method is called ab initio method or first principle of differentiation. Let y is equal to f of x be a function. Then suppose this x changes to, suppose the value of x changes to x plus del x, where del x is a very, very small, minute quantity. Then corresponding change in the output variable y is del y. Output variable y is del y. So we can write y plus del y, that is equal to f of x plus del x. This is a change in input variable and the corresponding change in the output variable is del y. Let this be equation number 1 and this be equation number 2. Now equation 2 minus 1 implies y plus del y minus y equal to f of x plus del x minus f of x. That means del y is equal to f of x plus del x minus f of x. Now divide this expression by del x. So this expression becomes del y by del x is equal to f of x plus del x minus f of x divided by del x. Since the change in x, that is del x, is infinitesimally small. So apply limit del x tends to 0 on both sides of the equation. So LHS become limit del x tends to 0, del y by del x is equal to limit del x tends to 0, f of x plus del x minus f of x by del x. This time limit del x tends to 0, del y by del x is called f dash x or is equal to dy by d. Term is the rate of change in the output variable y, in y, with respect to the input variable x. That means dy by dx is equal to limit del x tends to 0 del y by del x. Here, this term del y by del x is a ratio, but this is dy by dx is not a ratio. Dy by dx indicate d by dx of y, or this is also indicated by d1y. 1 stands for first derivative, d2, this becomes 2 means for second derivative, and 3 for third derivative, etc. Where d1 is equal to d by dx. The fourth point is dx by dy. That is equal to limit del y tends to 0 del x by del y. 1, this is equal to 1 by limit del y tends to 0 del y by del x. This is our dy by dx. So this is equal to 1 by dy by dx. That implies dx by dy is equal to 1 by dy by dx. But d square y by, that is the second derivative of y, with respect to x, that is d square y by dx square, not equal to 1 by d square x by dy square. D square y by dx square is equal to d by dx of dy by dx. That is the derivative of dy by dx with respect to x. Y is equal to sin x. Sin x. Let this x changes to x plus del x, and the corresponding change in y is y plus del y. So x is changes to del x, y is changes to y plus y, x is changes to del x, and the y is changes to del y. So we can write y, this is like equation number A, and y plus del y is equal to sin of x plus del x. Let it be equation number B. Now B minus A implies del y is equal to sin of x plus del x minus sin x. The limit del x tends to 0. So this implies limit del x tends to 0 del y by del x. That is equal to limit del x tends to 0 sin x plus del x minus sin x by del x. So this is a form sin C, sin A minus sin B. That is equal to 2 cos A plus B by 2 into sin A minus B by 2. That is limit, this is equal to limit del x tends to 0 2 cos this plus x plus del x plus x by 2. That means x plus del x by 2 into sin x plus del x minus x, that is del x by 2 whole divided by del x. Now this is equal to, apply the limit del x tends to 0. So this term become 2, so this term become 2 times cos x plus 0 by 2, cos x into limit del x tends to 0 sin del x by 2 by del x. This 2 is taken to here. So this becomes like this. Now what is the value of limit del x tends to 0? This is from limit x tends to 0 sin x by x. This is equal to 1, our standard limit. So this is equal to cos x into 1. Therefore, dy by dx of sin x is equal to cos x. This is the first principle of differentiation. Now, we know that your derivative or differential coefficient is equal to dy by dx. Actually, what is the physical significance of dy by dx? Physical significance of derivative or differential coefficient. Consider a function y is equal to f of x. I'm going to draw the graph. Let this be the graph of the function. X-axis y and y is equal to f of x. Let this function be this. This is a y is equal to f of x. Now, I want to find, this is a function y is equal to f of x. I want to find the derivative of this function with respect to this point. So I draw a tangent at this point. So the tangent touches this point. Let this is equal to theta. Then dy by dx at this equal to tan theta. Now what is tangent? What is tangent? This is a tangent. Right. Tangent is equal to the limiting case of secant. Okay. This is our curve. Then a line cuts the curve at 2 points is called secant. So this line is a secant. This cut the curve at this point and at this point. So secant cut the curve at 2 points. And tangent will not cut the curve, that will touch the curve at 1 point here. Now, I want to find the tangent tangent of this curve at this point. Okay. So what you have to do? What is the tangent at this point? The tangent at this point will comes like this. Okay. So consider this is a rod. Consider this as a rod and apply some force here. This is fixed. This rod. Consider this is a rod. This rod is fixed at this point. Then apply some force here. Apply some force. So this point will move down. So this line will goes like this. Again apply. So this line will goes like this. And finally, this line will goes like this and touches only at this single point. So this line, this rod is fixed and applying the force here, this portion will move up. This portion will move up. And this curve coming down, this curve is going up. And finally, finally this curve will meet only at one point. This coming, the next this will come like this and so on. This is a tangent. So a secant is a line that cuts at 2 points, but tangent is a limiting case. That means so this is our secant. This is our curve y is equal to f of x. Now we want to find the tangent at this point, tangent of the curve at this point. What is the difference in this height? This difference between these 2 points is, this is the del y difference, and difference in x, this is del x. Now we are applying, this point is fixed and we are applying the force here. So this is moving down and this portion is moving up since this is fixed. So when this reaches at this point, what happens? When del x, when we are pushing this line going down, so this reaches this point and this is moving up at this point, then what is the difference in height? Difference in height is, this is the del y. Now this is the del y. Del y is decreasing and the corresponding del x is, this is the corresponding del x, and del x is also decreasing. Then again pushing from this point, this will reach, like this will reach at this point. Okay, then again cutting 2 points. So again del s is decreasing. This is del x now and this is our del y. So when this point is moving towards this and finally and reaching and touching at this point, del x tends to 0 and del y tends to 0. Definition of differentiability. Consider a function, this be a function, y is equal to f of x. At this point, let the value of x is a. At the value of x is a. Then what is the value of y at this point? At this point, the value of y is equal to f of a. F of a. Right. So consider a point at a distance h from a. So this distance is h. So this is a plus h. So what is the value of the function at this point? This is equal to f of a plus h. Then this difference in height between these 2 points is f of a plus h minus f of a, this height. And the coordinate of this point is, coordinates of this point is, x coordinate is a and y coordinate is f of a, that is a comma f of a. And coordinate of this point is, f of this point is a plus h is the coordinate, comma y coordinate is f of a plus h. This is a coordinate at this point. Now draw a secant. Now draw a secant between this point and this point. This is the secant, cuts a curve at 2 points, at this point and at this point. Now we know that we want to find the tangent at this point, and tangent is the limiting case of secant. Now h moving towards A. H is moving towards A. That means H is moving towards A. Now let this point is moving towards A. So what happens to the value of the function? Let at this point, the value of the function is this. Now this is our f of A plus h and this is f of A. So this height decreases. Then again this h is tending towards A. Then what happens? This height is, now this is the height. So the difference in height, difference in height between these 2 points is again decreases. So again this is moving towards, so the curve, this point of the secant will moving towards this point and finally reaches this point. So at this point, finally, and when h is moving towards, when this point is moving towards A, this line cutting will moving along. This height decreases. This height is decreases. And when this touch, secant touch at this point alone, then we can draw the curve like this. And this is our tangent. Condition we can write as f of, this height is f of A plus h, so the change in y, this is a change in y and this is a change in x, change in y and change in x. And our derivative is defined as change in the ratio of change in y divided by the ratio of change in x. So we are approaching from right side. So we are defining right hand derivative. Since we are moving towards A from right side. That is, right hand derivative is this del x tends to 0, the difference in y variable divided by difference in x variable. Difference in y variable is the f of A plus h minus f of A. And difference in x variable is A plus h minus A. So, right hand derivative. And right hand derivative means x is approaching from the right side of A. This is equal to limit h tends to 0 f of A plus h minus f of A divided by, this is a change in y variable, f of A plus h minus f of A, this height, divided by this width. This width is A plus h minus A. That is equal to limit h tends to 0 f of A plus h minus f of A and A get cancelled, divided by h. Similarly, consider the C from, this is our A and this point is A comma f of A. Now consider a secant from left side, secant drawn from left side. Let this distance is h. So this point is represented by A minus h. This height is represented by f of A minus h. So the coordinate of this point is A minus h comma f of A minus h is the coordinate of this point. Now move this. Now h is approaching from left hand side of A. We are moving towards A. So this point is moving towards A along this curve. This point is secant, this point secant cutting like this and like this, etc. So this point is moving towards A. Then again the secant is moving like this. So this is the difference. Now when this difference is small, that is tending towards A, that is this tending towards A, this height become tending towards, the difference in this height, that is a difference between these two variables should tend towards 0. That is called left hand derivative. hand derivative. That is limit h tends to 0. F of the value of the function is, value of y is f of a minus h minus f of a divided by a minus h minus a. This gets cancelled. So this is equal to limit h tends to 0 f of a minus h minus f of a divided by minus h is the left hand derivative. And derivative RHD is equal to limit h tends to 0 f of a plus h minus f of a divided by h. This is divided by f dash a plus. That is, we are moving from the right hand side. Then left hand derivative, that is equal to limit h tends to 0 f of a minus h minus f of a divided by minus h, that is denoted by f dash a minus, because approaching towards a from the left hand side of the a. Then to be differentiable function is set to be differentiable if left hand derivative is equal to right hand derivative, if LHD is equal to RHD, or f dash a minus is equal to f dash a plus f dash a. Then the function is differentiable. F dash a is equal to limit x tends to a f of x minus f of a. F dash a means the derivative of the function at this point a. That is, f dash a is equal to limit x tends to a f of x minus f of a divided by x minus a. Now this is form, when putting x tends to a, this becomes f of a minus f of a by a minus a. That is 0 by 0 form. So by Hospital rule, differentiate the numerator and denominator. This is equal to limit x tends to a, the derivative of this is f dash x. This is a constant, the derivative is equal to 0. By derivative x is 1 minus 0. Now put a, x is equal to a, this becomes f dash a. Not. Let's consider the function. If this, let this is a point, we are drawing a tangent at this point. If this function is differentiable, then the tangent is unique at this point. If function is differentiable, then LHD is equal to RHD and the tangent is unique. So this tangent is from this side and this side, there is only one tangent at this point. Now consider the function mod sin x. Mod sin x. What is mod sin x? So at this point, so approaching from left hand side, the tangent is going like this. This is the tangent. And then approaching from this side, from the right hand side, tangent will goes. This is our tangent. So these tangents are not same. Not same. Tangents, so the tangents are are not unique. Not unique. So mod sin x is not differentiable at this point. Similarly, f of x is equal to mod x. Mod x. So this mod x function, this is the graph. So tangent is at this point is not unique. So but this function is continuous. Function is continuous, but not differentiable. Not differentiable. This tangent is not unique. We have two tangents at this point. Now consider y is equal to x raised to 1 by 3. This is a graph of x raised to 1 by 3. So this is not differentiable at this point. So if the functions have some sharp corner, then it is not differentiable. If f of x is equal to mod x minus a into phi of x, where phi of x is a continuous function, f dash a plus is equal to question. That means this is the right hand derivative. We are moving from equal to limit h tends to 0 f of a plus h minus f of a divided by h. So this is equal to limit h tends to 0. What is f of a plus h? F of a plus h is mod of x is replaced by a plus h. A plus h minus a into x is replaced by a plus h. Phi of a plus h minus f of a, that is 0 x means a minus a mod a minus a into phi of a. This divided by h. A and a get cancel. This time a minus a is equal to 0. So this is equal to limit h tends to 0 mod h into phi of a plus h by h. So when approaching from right hand side, mod h is equal to h. For h tending towards 0 plus. H is equal to h for h greater than or equal to 0, and for minus h for h less than 0. So in this problem, is approaching from the right side of a, right hand side of a. So h is equal to h. So limit h tends to 0, h into phi of a plus h by h. These two get cancelled and put h is equal to 0. So this is equal to phi of a.